Recording the vodcast for homework. Come here, little pen. Where you at? Homework 5.2. It's taken from the 2007 AP exam for your response number 1, so we know it's an equilibrium problem. I'm going to do something a little bit different on this problem. I'm not going to give you the answers directly, but I'm going to give you the setup to how you find them, just to get you guys a little bit more involved with these problems. So if it's hard to understand initially, there's a lot of different ways we can tell we're talking about an equilibrium problem. Number 1, we're on free response number 1. Number 2, we've been given double-sided arrows. 3, it's a Ka problem, and this is a weak acid, HF. So we're going to have partial ionization going on. Right? So on free response number 1, you always want to set up your ice table, and you always want to write your Ka statement. Now I'm going to let you go ahead and do that. I think that you guys are really, really good at setting up your ice tables and writing your Ka statements. So when you do that, you are going to actually automatically answer the first question, which is basically write the equilibrium constant expression. So you will have done that right there. In this problem, it says calculate the molar concentration of H3O plus, there's H3O plus right there, in a 0.4 molar solution of HF. There's HF right there. So this here, this is question mark. And this here, this is going to end up being X. So when you do this problem in your ice table, you have Ka, you have question mark, and you are going to solve for X. And in order to do this problem, you have to do a square root. So you're going to set up this problem, you're going to plug everything into your ice table. You've been given Ka, you've been given question mark, you're going to solve for X, and you need to do a square root in order to do this. Now H3O plus is basically, for the sake of this problem, same thing as H plus. But that does not matter because they're not asking you for the pH. They're just asking you to solve for X. All right, so please let me know if you have any problems with that. Again, A is asking you for Ka, which you should have done initially by doing the Mr. Musallam ice script. In B, they're asking you to solve for X, which is the H3O plus concentration. It's actually also equal to F minus, this Bronsted base. And they give you question mark and they give you Ka. And you know you're doing it right if the last thing you do is a square root. So this should be the last thing you do. Okay. So let's go down here to the next problems. In the next problem here, they're taking this weak acid HF and they're adding OH minus. They're titrating it. So just as a reminder, what they're doing here is they're adding OH minus to a weak acid, so the pH is going to rise, but it's going to increase gradually because they're titrating a weak acid. There's the buffer zone. There's the equivalence point. Okay. HF is a weak acid. All right, so let's go through and answer these questions. You don't have to do E. So for part C, they say calculate the number of moles of HF remaining in the solution. And they tell you that you have 25 milliliters of a 0.4 molar solution of HF, and you have 15 milliliters of a 0.4 molar solution of NaOH. So let's look at this initially. If I rewrite the reaction, I have HF plus OH minus goes to H2O liquid plus F minus. And initially, I have 0.015 liters. Oops. I have 0.015 liters of a 0.40 molar solution of OH. And I have 0.025 liters of a 0.40 molar solution of HF. So I remind myself that molarity equals moles divided by liters. So moles equals molarity times liters. So this molarity times that volume is going to give me 0.01 moles of HF. And this molarity times this volume is going to give me 0.006 moles. These are going to react with each other, and they're asking me to calculate the remaining HF moles in the solution. So 0.01 moles is going to react with 0.006 moles in a 1-to-1 ratio. So I'm going to have some moles of HF remaining. If they're reacting in a 1-to-1 ratio, I only need 0.006. So I need 0.006 moles here. Okay. So the moles remaining are simply, and I'll go down here and do it down here, 0.01 moles. So this is remaining HF moles minus 0.006 moles equals 0.004 moles HF. Okay, so that's the answer to C, 0.004. Okay, now that's fine for that. I kind of walked you through that. Now they're asking you to calculate the molarity of the F minus ions in the solution. So I'm going to give you hints on this one and let you guys figure this out on your own. So my big hint is molarity equals moles over total volume in liters. Okay, so the moles of HF produced are going to be the same as the moles of OH minus, since this was your limiting reactant. So you have 0.006 moles of HF. Okay, and that is what is going to go into the numerator of this equation. Now your goal is to figure out what the volume will be here, and the hint is you have 15 milliliters of NaOH and you have 25 milliliters of HF, and those two things are combined. Okay, they say the volume is additive. So those two things are combined to produce the total volume found here at the end of the reaction. So to get the molarity of F minus, you take the moles of F minus, which was 0.006, the same as the hydroxide ions, divided by the total volume, which is going to come from these two numbers in liters. Okay, hope that was helpful, guys, and I'll talk to you tomorrow. Bye-bye.